Hello and welcome to Tensar Ground Coffee, a few minutes on ground engineering to enjoy while having your coffee. Well, here we are at the Tensar Technical Centre in Blackburn in the GeoGrid Torture Lab. So what we do to our geogrids here is we hang them up from the ceiling and we put these weights on the end and we leave them stretching for years. So why do we subject our lovely geogrids to this torture? Well, it is to determine their creep properties. So these polymers, these geogrids, under a sustained load, they do have some creep strains. So they will continue to extend just a little bit under a sustained load. So when we have these installed into a structure or a slope, so a structure such as a mechanically stabilized earth wall, the design life could be as much as 120 years. So we need to know how that grid is going to perform over that full 120 years. So one way to do that is with creep testing. So you leave these geogrids hanging for as long as possible and you measure the extension over time. Now, the relationship between strain and time follows a log time relationship. So if we can get the testing up to 12 years, that's only one log cycle short of the 120-year design life. So that's only a little bit of extrapolation. So it's good to get up to 12 years. So some of these have been here for over 12 years. So these ones, for example, actually started in 1994. So well over 12 years. They did 12 years at the previous lab, then the lab had to move. That's the worst thing to happen to a creep lab, is to have to move. So you have to unload everything, take it to the new lab and reload. So strictly these tests aren't compliant anymore, but for academic interest we do continue to load them. And we saw that when we reloaded them, the deflection curve did return to the same course that was followed previously. So we're getting a lot of useful information from these ones. So those ones were reloaded, but we do have other ones that have been loaded for over 12 years uninterrupted, such as these ones here. So we've got the full deflection behavior under different loads for 12 full years uninterrupted. And then it's so what you can do with that data, as I say, you can extrapolate it for 120 to 120 years. But if you need that information earlier, then you can test at higher temperatures. So we actually have labs here. This one is 20 degrees. We also have a 10 degree, 30, 40 and 50 degrees Celsius labs. So why right up to 50? Well, then the geogrids do creep more quickly at 50 degrees C. So we can then use shift factors to go back to normal temperatures experienced by the grid in service, such as 20 degrees or 10 degrees. So those are ones that have been there for a long time, for over 12 years. We've got some biaxials that have been here for a long time as well. We need those for load transfer platforms. But also we have some newer grids. So here's a sneak preview of a future generation product that will be used in walls and slopes. So we like to get the creep testing done as soon as possible, so we start getting that data and we can use the shift factors to predict the behavior over long periods of time, so that can go into the design methods so that we can design structures with these new products. And some of them are loaded really heavily. So this one, for example, 780 kilos here, so that's 3/4 of a ton on 3 strips of plastic. So this product really is stronger than it looks. Okay, I hope that's given you a useful overview of the Creep Lab here at Tensar. That's all for this episode of Tensar Ground Coffee. Thanks for watching and see you next time.